Good evening, good evening, good evening, good evening, everyone. Good evening, everyone. Okay, good evening, everyone. Let's discuss this ABG question. Uh, the question says that pH is 7.3, partial pressure of carbon dioxide is 28, bicarbonate is 14, sodium is 140, and chloride is 100, and partial pressure of oxygen is 90. So now let's discuss it. Since pH is 7.3, it is acidosis, because we all know that the normal the pH which we take for ABG analysis, which is considered normal or cutoff, which differentiate between acidosis and alkalosis, is 7.5. This is for simplification, and it is not a hard and fast rule that let's assume 7.39 is acidosis, 7.41 is alkalosis. It's not a hard and fast rule. Just for convenience, we are taking this 7.4 as a cutoff. So since 7.3 it is acidosis, next partial pressure of carbon dioxide is 28. The normal partial pressure of carbon dioxide for calculation what we take is 40. So carbon dioxide has decreased by 12 units. So if partial pressure of carbon dioxide is decreasing, that should have actually caused alkalosis, right? Because carbon dioxide contributes to acidosis. Decreasing carbon dioxide should cause alkalosis. That means the pH should have been increased, but pH has decreased. So this is not the cause for acidosis. So the cause for let's go to bicarbonate then. Bicarbonate is 14. Normal value what we take for bicarbonate is 24. Bicarbonate has decreased by 10 units. So we all know that if bicarbonate contributes for alkalosis, a decrease in bicarbonate will lead to acidosis. And in this case, like it is fitting that a decrease in bicarbonate is causing alkalosis. So the primary disorder is metabolic acidosis. Here now step 2. Step 2, let's talk about compensation. We all know that in metabolic acidosis we take Winter's formula. Winter's formula says that PCO2 is equal to 1.5 times the bicarbonate plus 8 plus or minus 2. So according to this, the carbon dioxide partial pressure of carbon dioxide should be 1.5 into bicarbonate is 14. So plus or minus 8 minus 2. So 1.5 into 14 is 21 plus 8 is plus 8 is 29. So it should be plus or minus 2. That means the partial pressure of carbon dioxide's value should be in between 27 to 31. So we know the present carbon dioxide value is 28. So this shows that the value 28 lies in between 27 to 21. So there is adequate compensation. Step 3. Now let's talk about anion gap. Anion gap. We all know that anion gap formula is sodium minus chloride plus bicarbonate. Okay, this will give us anion gap. So sodium is 140, chloride is 100, bicarbonate is 14. We get 140 minus 114, which is equal to 24. And we all know that anything greater than 17 is considered as high ion gap. Since 24 is greater than 12, we are going to consider it as high ion gap. So final answer is metabolic acidosis with adequate compensation with high ion gap, simply called as HAGMA, high ion gap metabolic acidosis with adequate compensation. That's it, guys.